Tired of manually running your Python scripts every single day? In this tutorial, you'll learn how to completely automate script execution using the Windows Task Scheduler so your code runs like clockwork. Welcome to this hands-on screencast on Windows automation. Python is amazing for writing scripts that scrape data, generate reports, or clean up files. But running them by hand defeats the purpose of automation. Today, we are going to bridge that gap by connecting a Python script directly to the Windows Task Scheduler. By the end of this session, your computer will execute your code automatically on a fixed schedule, without you ever having to touch the terminal. Before we write any code, let's understand how Windows Task Scheduler interacts with Python. The Task Scheduler is a built-in Windows utility that acts like an alarm clock for your operating system. Instead of playing a sound, it triggers an executable program at a specific time, on a specific day, or even upon system startup. To run our automation, the scheduler needs two vital pieces of information: the absolute path to the Python interpreter, and the absolute path to your Python script file. Without full paths, Windows won't know where to look. To prove our automation works, we need a script that actually does something tangible, like writing to a file with a timestamp. This allows us to verify execution even when no terminal window is open. Let's write a self-contained Python script that opens a text file in append mode and logs the current date and time. Notice how we use the built-in datetime and pathlib libraries. This ensures that every time the script is triggered, it leaves a clear footprint on your hard drive. Let's type out this code. Now that our script is written and tested, we need to prepare the command that Windows Task Scheduler will run. In the Task Scheduler GUI, you configure a new basic task, give it a name, and set a trigger like daily or hourly. The most critical step is configuring the action. You must select Start a Program, and in the Program or Script field, you provide the full path to your Python.exe interpreter. In the Add Arguments field, you provide the absolute path to your script. Keeping paths enclosed in quotes is essential if any folder names contain spaces. When tasks run in the background via Task Scheduler, standard output streams like print statements are discarded because there is no active console window. To make our script robust for unattended execution, we should ensure all errors and statuses are explicitly captured inside our file logging mechanism rather than relying on the console. Let's update our script to include a try except block so that if anything fails, the error message gets safely appended to our log file instead of failing silently. One of the most common pitfalls when scheduling Python scripts is working directory mismatch. When Task Scheduler runs your script, it might default to the System32 folder instead of the folder where your script lives. This means relative file paths in your Python code will fail to find local assets, CSV files, or configuration data. Always use absolute paths in your scripts or programmatically set the working directory using pathlib. This guarantees your code runs identically whether you launch it manually or let Windows trigger it. Let's modify our script to explicitly anchor all file operations relative to the script's actual parent directory rather than relying on whatever folder the operating system decides to launch it from. By using __file__ in pathlib, we make our script completely portable and safe from working directory bugs in Task Scheduler.
Here is the updated code snippet implementing robust path resolution.
Another critical consideration for scheduled tasks is security permissions and user context. You can configure your task to run only when a specific user is logged on, or whether the user is logged on or not. If your script interacts with network drives, local databases, or restricted folders, make sure the user account assigned to run the task has adequate read and write privileges. Also, check the option to run with highest privileges if your script performs administrative tasks. Let's add a final operational check to our script. When tasks run autonomously, it is extremely helpful to record system metrics like Python version and execution status to ensure everything is operating in the expected environment.
Here is a script that logs environment details alongside our execution timestamp.
Even with careful planning, tasks can sometimes fail silently due to expired passwords, missing dependencies, or network timeouts. To troubleshoot, you should always check the History tab inside Windows Task Scheduler.
It provides detailed error codes, such as the infamous result code 0x1 for script errors or 0x41303 for tasks that are still running from a previous instance.
Combining Task Scheduler history with your own custom file logs gives you complete visibility into your automated workflows.
You've now learned how to bridge Python in the Windows Task Scheduler, transforming manual scripts into fully automated background processes. By using absolute paths, robust error handling, and file-based logging, you can ensure your automation runs reliably without supervision. Thank you for watching, and happy automating!